In this exercise, I will consider a method using lidar in order to detect walls in a rectangular room. So the lidar we'll use is Okuyo type, so a plain radar. The robot has no compass and it is not needed here. And we don't know the exact shape of the room except that it is rectangular. So we don't know its length, we don't know its width. The first question, we have some points of R2 and we want to use a least square method in order to detect a line, and we'll use a specific form where the parameters of the line will be alpha the angle and d the distance to 0. So I will explain this. I have represented here an Okuyo type lidar, and it is in some kind of robot like this, for instance, with wheels. Okay, and we have walls. Let's say like this, it is a wall like this, but we have many of them because we are in a rectangular room. So I present here a part of two walls, one wall and a part of two walls, and we understand that Okuyo will send something like this, and if I see from above, I will represent in the robot frame, so it is in the robot frame, some points like this corresponding to these points. So it is in the robot frame. It means that here, if I have this, the robot will see something like this, with y corresponding to front and x, let's say, to right. But of course we have plenty of outliers because we have, let's say, humans here or tables or whatever. So we may have some outliers in many places. So we want a robust method which is robust with respect to this. So I will to represent a line, for instance, this one could be the baseline corresponding to one wall, here another wall, but I assume that I consider only points in the first question, only points on the same wall. So how I can represent the line? So I have to represent a line with parameters. I can use what we call the explicit form, and the explicit form has the form a equal ax plus b, where a and b are the parameters. I have also the standard form to represent a line, which is yx plus bx plus c equals 0. So here we can see two parameters, a and b, and here three parameters. But this one has some singularities. For instance, I cannot represent vertical line like this one. Okay. This one, the second one, the standard form, has no singularities, but it is over-parameterized. I mean, there is different set of parameters a, b, and c which correspond to the same line. And also, we want to use here an explicit form to represent line, explicit form. And the explicit form as is the following. Let's say P1 plus P2, excuse me, P1, let's say X plus P2 Y equal to 1. So again, I cannot represent a line that goes through 0, but since my lines are not on the robot, it will be perfect here. So assume that I have many lines. I should satisfy this type of equation, and I will have for all points, so this is the point I, this is point I plus 1, and so on. So here my point will be like this. And if I represent all my points that are assumed to be on the same line, at least for the first question, I can represent into a matrix form the equation that links my parameters to my measurements. So here I will have something like x1, y1, x2, y2, and so on, xn, yn, because I have endpoints. With in my problem n equal 512, p1, p2 equal 1, 1, and so on 1 due to the one on the right. What I want to find is the best p which goes through all lines. So for this I will use the least square formula, which tells me that the best one in the least square sense, if I call this matrix A, I will have p hat equal A transpose A minus 1 times A transpose multiplied by 1, 1, and so on, by this vector. So it is the least square formula. So of course, this formula corresponds to x, so p1 I will call it cos beta divided by d, plus y sine beta divided by d equal to 1. So if I know p1 and p2, it means that I know beta, so this one corresponds to d and beta, or p1, p2. So there is a correspondence between d, which is positive, and beta, and p1, p2. So if you want, here in my problem, d will correspond, if this is my line, d will correspond to this distance, and beta will correspond to the orientation of my line, so the cos and sine correspond to the normal vector to the line. So this least square method gives me p. As a consequence, I can conclude that d hat is equal to 1 divided by the norm of p hat, and beta hat corresponds to the angle of p hat, so angle of p hat. So by angle I means if I here I have p hat obtained by the least square method, beta will correspond to this, and to get this I use arctangent with two arguments of p2 hat, p1 hat. Question number 2, the lidar has an aperture angle of 180 degrees, so it means that it is only able to see front, left, and right, but not back. It returns 512 points in its own frame, and this is illustrated by the figure. And the data are stored in the file lidar data. So we'll open it and draw this. We can see that something like 30% of the data are outliers, so that means they do not correspond to goals. They may correspond to obstacles, for instance. And 70%, it's an approximation, we don't know exactly, but 70%, just to give an idea, are inliers. It represents two distances to the wall. That's why we want a robust method. first I will draw them, and then I will have to group the data by groups of 10 data, and from this I will use the least square method to detect lines as explained in the previous question. The robot is at 0, 0, so it is like here, like this. I represent like this, with left and right, and we understand that it will collect some points like this, and this may correspond to some obstacles. This is why we have lines like this that are all corresponds to points, and these lines are explained because of the position of the robot respect to the wall. So we can see the walls. We know that there is 4 walls. We can see here one wall, another wall, another wall, and the last wall I cannot see it because this is behind the robot. So I can see only 3 of them. And we can understand that the situation is not easy because the robot is very close to one of the walls. And also due to the fact that you have many outliers. The first step is to draw these all these points. I will use a Python program. I first load the CSV file, which contains all data here. Then I will have the length of this table will correspond to M, this one. So I will make after a group of 10, that's why I have n equal to 10, but it will be done later. I will select x and y, which corresponds for each point. It will be a table which corresponds to the x I coordinate and y I coordinate in the frame of the robot, of course. I will initialize a figure. For this, I will use a roblib library. I will plot x and y and print x and y. I will start with this program. I run the program and I obtain here the figure. I can see here x and y with 512 for x and also for y. My room is rectangular, like this. And my point will be like this. So I assume that I have no problem with some outliers like this, I would say. And here they will be like this. And when I will group them by group of tens, either they are like this, could be nice, with few outliers, let's say this one, or they could be also like this. So it corresponds here, we can understand that we have a good line here, but here I do not have good lines. So some groups will be quite adapted to walls, some other, like this one, this group will not be adapted to walls. Moreover, when I see a wall, I do not see which one it is. It could be, for instance, this one, but it also be this one, or this one, or this one. So I don't know this. But they are equivalent in some senses. For instance, the orientation of this wall, this wall, this wall, and this wall, this orientation, are all correspond all by an angle of p divided by 2. So I would say that an angle, an orientation for a wall, let's say beta 1, is if it is consistent with one wall, and if the beta 2 is consistent with another wall, I would say that they are equivalent, like this. So it means they are equivalent if b2 equal b1 plus k, which is an integer, multiplied by pi divided by 2. Okay. Now, this is equivalent to say that I multiply by 4, 4 beta 2, it equals 4 beta 1 plus, plus 2k pi. Now, this corresponds to one angle, and one angle, it means that these two angles are equal. I can also use the sine and cos to avoid this one because I don't know k. So to avoid this problem, I will say that two angles are equal if their cosine and sine are equal. So it means that this for beta 1 and the same for sine. Beta 1. Okay, so in this formulation I don't need anymore the k. So what I have done for each alignment group of 10 points like this, I will generate an angle, a distance and an angle. So the angles will be like this. Some of them will correspond to one wall, some of the one to another wall, and I can see that I will have some kind of cross like this. But I also have some outliers. It means that I have few of them like this. So to make the correspondence between this group, I multiplied here the angle by 4. Okay, so I multiply by 4. And this group will all go to the same region, like this. So it means that this one will go here, this one also, all of them will go to the same region, and the outliers will go somewhere else. But due to the multiplication by 4 of the angles, I have grouped them. Now, what I will do, I will select for all of them the cosine and the sine, like this. And I have some outliers like this. Then I will take the median, so some kind of middle, so which separate R from the left, R from the right, so it is a median. The median for the cosine and the median for the sine. Then I will generate the corresponding angle, and this will correspond to some kind of average angle of all this one. But due to the fact that I have decomposed in the cosine and sine, I was able to avoid the singularities that I could have if all the angles would have been here, and if I would have considered the angle instead of the cosine and the sine. So it means that in a trigonometric circle, I avoid the singularity around pi. The program to detect the direction of the walls is given here. First, I select 512 points, and I store them in X and Y as explained previously. I will form my groups here, and J is a number of the group I consider. So I select the group taking 10 consecutive points because n is equal to 10. Then I will form my matrix A of 10 points. I will use my least square method to find the parameters p hat for the jth group. Then I will select the distance and the corresponding angle as explained in the previous question. What I will do here, I will compute the residue. So if I have something like this, if the residue is small, then it means that I have a good alignment, and I will draw it green. Otherwise, if the residue is large, I will plot them red. Then here, what I do here, as explained previously, I will consider in the group all angles. I will multiply by 4. I will take the sine and cos. Then I will compute the median and it will give me an angle. This angle has been represented here previously. Then I will come back here by dividing by 4 and I will obtain 1 point, which will be one of corresponding angle, one of the 4 walls. So it can be, for instance, this one. And then from this, I will be able to deduce orientation for all of the walls thanks to rotation by p divided by 2. Okay, so I will be able to return one of the correspondent for the 4 walls. I switch to Python. I will run this program and I obtain this. Okay, so I can see in green the good alignment and in red something which corresponds to outliers. So I can recognize here some corners and some true points that have not been detected due to the fact that I have selected some groups. So the green are good, the red are not selected because the residue is too large. Here I can see the beta hat corresponding to one angle of the representant of one of the walls. From beta m, I am able to select the orientation for all other walls, but I am not able to identify which wall it is. It is just one representant here. So in the question number 5, I have to write a program which localizes the walls, and also I have to draw all the walls. I have computed in the previous program an estimation of one of the wall, and the orientation is called beta hat, and it was corresponding in the program by beta m, m like median. So what about the case wall? It can be obtained by beta hat by the following relation: rotation by p divided by 2, like this, where k belongs to, let's say, 0, 1, 2, and 3, because I have 4 walls. Now, if I have an alignment, a group of 10 points, then the alignment is the J alignment is beta J dj, like this. It will be equivalent to k, excuse me, it will correspond to the wall number k if the angle beta j is equal in terms of angles to beta k. So it means that the cosine between beta j minus beta k is equal to 1, something like approximately equal to 1. So I will select them. I will say that this alignment corresponds to the number k. So it's better to use the cosine to avoid the modulo 2 pi problems, because two angles can be equal on the trigonometric circle, but due to the fact that they may differ from 2 pi, this equality may not be satisfied. This is why I put the cosine. So once I am able to select for each alignment which k it corresponds, then I will have walls like this with different type of alignment, let's say like this, with different distances, like this. So all of them belong to the same wall. have to do some kind of average, but due to the fact that I may have some alignment corresponding to outliers, I will use a robust estimator, so I will use the median. So this is why I will select which distance, so I will call it theta hat for the number k, so here it is the whole number k. It will correspond to the median of all distances dj. Okay, so here it will be let's say d1, d2, but I will select only those corresponding to the case rule with respect to their orientation. So this is why here I will select dj, but only such that k, so the k here, correspond to the wall I have for j. The corresponding program is given here. Okay. Here I consider all walls from k belongs to 0, 1, 2, 3. Then it will correspond to the angle associated to the kth wall. I will select all index E, so it's a set of index, the set of all j, such that the cosine between bj and bk is almost equal to 1, as explained before here, and it corresponds to this. Okay, so here it is a set of index. Then I will form the array corresponding to this index, so I will select only in my set of distances only those corresponding to the right angles associated to my wall number k. And if I have some alignment, because sometimes I do not have alignment, why? Because some walls are not able to be seen by the sonar, by the lidar. So I have to select this. Then I will compute the median as an estimator to have a robust estimation of the distance to the case wall. And then I will draw this. So I take a segment like here. I will translate by the right distance. I will rotate by the right angle. And then I will plot it. So this is my Python program. I run it. And I can see in blue the walls that has been reconstructed by the method. We can see 3 walls in blue, but 1 wall was not able to be seen because it is on the back of the robot.